Now, antibiotic resistance is the ability of bacteria to resist the effects of an antibiotic, which means that even if you're taking antibiotic, it's not going to have any effect on the bacteria because the bacteria have become used to that antibiotic. And this resistance is caused by misuse or overuse of antibiotics. So example of misuse is that even if the person is not suffering from bacterial infection, you're still prescribing antibiotic. So this is a case of prescription as a preventive measures. So you're trying to, so the doctor might think that the patient might suffer in a few days, might suffer from bacterial infection. So I'm just going to give antibiotic just in case. So this is prophylactic medicine. So it's a preventive measures. So this can cause the resistance to antibiotic. Or you can prescribe penicillin for minor illnesses. So things that the body would naturally heal, but you're prescribing antibiotic for this. Another misuse is failure of patients to complete the course of antibiotics prescribed by the doctor. Normally, if you're prescribed antibiotics, you will be given a course of 3 to 5 days. So you will have to take the antibiotic whether you are feeling better or not throughout the 3 to 5 days. But many patients, they take the antibiotic 1 or 2 days and then they say, okay, I'm better now, I'm going to stop taking the antibiotic. So when you do not complete the course, this causes the bacteria to become resistant to the antibiotic. So in the case that the course of antibiotics is not complete, what happens is that the bacteria starts to mutate. It develops an enzyme called penicillase, which prevents penicillin from binding to the enzyme that produces the cell wall. So the bacteria is becoming more resistant to the antibiotic. So over time, bacteria with high levels of penicillase become dominant and penicillin is not effective anymore. So now, let's say a person is sick. The person takes antibiotic for 2 days instead of 3 days. So after 2 days, the person starts to feel a bit better. But during the days that follow, let's say on day 3, so the person now in his body has bacteria with high levels of penicillase, so mutated bacteria. So on day 3, you have mutated bacteria that are going to multiply now. Now, this mutated bacteria, so you can spread it to another person, so you infect someone else, or this bacteria is going to multiply in the body and make the person more sick. Now, the person becomes more sick and thinks that, okay, I'm sick again, I'm going to take penicillin. But now, because of the high levels of penicillase in the mutated bacteria, penicillin is not effective anymore. And even the person who has got the infection from, let's say, patient 0, say this is patient 0. So the person who got the infection from patient 0 now is not going to be cured by penicillin. So they will need another antibiotic. Now, to solve the problem of antibiotic resistance, we're going to modify the side chains in penicillin. So for example, here, so this is the structure, the main structure of an antibiotic. And if you look at here, this is R. R means side chain. So they can replace R with different groups. So as you can see here, so if you replace it with this R group, you get penicillin G. You have penicillin V, amoxicillin, methicillin. So these are all the different side chains that you can attach here. And These are going to reduce the occurrence of penicillin-resistant bacteria. And sometimes there are diseases that cannot be cured by only one antibiotic. Therefore, we give a cocktail of different types of antibiotic. This is the case for tuberculosis. So the bacteria that cause tuberculosis is extremely resistant to penicillins. Therefore, we give a mixture of different antibiotics. Maybe these antibiotics have different modes of action as well. Now, some antibiotics are also not taken orally because they are broken down by stomach acid. So, the side chain can also be modified so that there is increased resistance to the breakdown by stomach acid, which means that antibiotics can then be taken orally. So, for example, ampicillin is a modified penicillin and it can be taken orally, whereas penicillin G needs to be injected because it will be broken down by the stomach acid. So this is an example of the side chain for ampicillin.